Okay, so we need to start with question number 14 here. And we have f of x equals negative cube root of x plus 1 minus 2. And we're asked to find the domain and range and graph this. Okay? And so if I tried to graph it right now, I don't have a lot of x's and y's. So the first thing I'm going to do is just go to the calculator. There's no sense trying to force myself to do everything by hand. I already do a lot of the math on this test by hand. I might as well do some of it in the calculator. So I'm going to go to the calculator. I'm going to go to y equals. And I need to know how to put a cube root into the calculator. I could type the negative piece, but how do I get a cube root into the calculator? There's two choices. Option number one, if you press the math button, the fourth option down here is a cube root. That's option number one. And if that's something you don't think you'll remember, that's something that would go on that note sheet. Cube root, math, go down 4. That's one option. The other option is to do parentheses. It would be x plus 1. And then I'm going to raise it to the 1/3. It does not matter which way you do it. I missed my 1. Whether you do the cube root or you do the 1/3 exponent, I prefer the 1/3 exponent just because I can think about what it means to have that 1/3 exponent. And I can go ahead and graph it. When I graph this, we get this zigzag shape, Z sort of shape. It could be S-shaped if it's the opposite sign. But as we look at this shape through here, okay, we really need to know where that center point is, where the pivot is, where it turns. Now, we can go to the table and start searching for it, but we should be able to find it just by looking at the original equation. The rule for always finding the vertex or the central point is taking the opposite of what's grouped with x, which would be -1, and then whatever number is added or subtracted out here, just the way it is, which would be -2. So -1, -2 is the point that this is all built around. Whatever happens on the right of it should be mirrored on the left, and vice versa. So with that in mind, when I go to the table to find data, I kind of want -1, -2 to be in the middle of my graph. So I've got that right now. It looks like -2, -1, and 0, -3 are also some good points. So I'm going to come over to -2, -1, and 0, -3. Is this enough points to graph it? The answer is no, because right now that's a straight line. I'm going to have to go out a little bit further to force the curve to appear. And you know, you can use any of these numbers. You just have to be willing to graph a decimal. But if you go all the way up to -9, you'll get 0. So that's 3, 4, 5, 6, 7, 8, 9, -9, 0. And then if I go to the right into the positives, eventually I think around 7. Yeah, 7 I get to -4. 1, 2, 3, 4, 5, 6, 7. -4, that'd be right there. And then my graph would look like the graph on the calculator. So there's my graph. You definitely need to include points in your graph when you do that. And then I ask you to give me the domain and range. Now the nice thing is cube roots always have the same domain and range, but you got to remember that or look at the picture and have that identified. Domain is which x's am I allowed to use? Well, this graph goes left forever and right forever. There are no breaks or holes. So that means we can use every number. That symbol, remember, means all real numbers. And then this graph, even though it looks like it flattens out a lot, it does continue to trend upwards slowly and downward slowly forever, meaning that it will never stop. So we can also say all real numbers. All cube root graphs always have all real numbers. If that's a note you want to write to yourself so you don't get that wrong on the test review, that's, again, information that you would put into it. If you were to put this in your note sheet, the dots, where'd they come from? Questions like that. You need to answer that kind of information more than show a picture of it, because the picture only does so much. All right, we're going to go over to 15. where we have f of x equals now the square root of x plus 3 plus 2. So instead of a cube root, it's a square root, but I'm still going to pretty much start the same way. I'm going to go to the calculator. I'm going to do the square root of x plus 3. And then the plus 2 needs to be outside of the square root. And when I graph it, we notice this is the graph that's the half parabola turned on its side. Okay? We really need to know where this first point is. There's a couple of ways to find it. We can look in the table, and if it's whole numbers, it should be pretty obvious. Or we just look at this, the opposite of what's grouped with x, and then whatever number's out there. So that first number would be at -3, 2. And if I look at the xy table, I'll see that as well. So 1, 2, 3, 1, 2. -3, 2 should be the first point in my graph. Sure enough, if I go to the table and go up to -3, 2, anything above that, anything more negative than that, anything left of that, it's going to give me an error. I need a couple more points. -2, 3, and 1, 4 look pretty good. 1, 4, -2, 3. And we can see that sort of parabolic shape on its side. We have to give the domain and range of the graph. Well, what's the domain? Well, domain, remember, is the x's, and range, of course, is the y's. I clearly cannot use any x I want for free. There are some x's that are excluded. For instance, there are no x's back over here once I go this way. It doesn't exist. Okay, none of those x's are part of my graph. So I have to say that it starts here and moves to the right. And so that's saying that x is greater than or equal to -3. You'll notice that comes from that special value that special first order pair we talked about. And here, the y's are all going up. The graph goes up from there. So that would make y get bigger than or equal to its lowest value, which is there at 2. Okay? That's the domain and range of the graph. We should be able to label that based on where we start and the fact that we go to the right from there. We could go up or we could go down, but a square root graph traditionally is going to go to the right for sure. Okay? Any questions? Okay. Remember, you can pause the video and go back, rewind, review. So on number 16, we're going to find the inverse of f of x equals 2x to the 5th minus 8. There are 2 steps to finding any inverse. The first step is the crucial step, and that is to switch the x and y. Very good. X equals 2y to the 5th minus 8. After that, once we've done that, it's always the same. Even though the problems look different, it's always going to go back to, can you get y alone? We always move the easiest stuff first. Go back to elementary school first and work your way up to high school. What's the easiest thing to move? Plus and 8. Adding is something we learned about back in kindergarten. We can manage that. X plus 8 equals 2y to the 5th. What's the next type of math that you learned about as you worked your way up through elementary school? Multiplication and division. So we are going to divide by 2. Now, you could try to break the x and the 8, go x over 2 or 1/2 x plus 4. You could try to split it. I'm not after simplification on this problem at all. I really just want to make sure that you understand the order of the steps in which you would clean it up. So, equals y to the 5th. And how do I get rid of a 5th power? Not a square root. You're on the ballpark.
Raise to the inverse?
Okay, I can raise it to its inverse power. What's the inverse of a 5? 1/5. Or I can just take a 5th root. That's the other option. I don't really care which method you use. You can raise this to the 1/5, because that would cancel the 5. And our inverse function, which you do not have to write, f inverse of x. I'm not going to come after you for it. It's nice if you can. It is x plus 8 all over 2 raised to the 1/5. Or, if you don't like the 1/5 power, it's just a 5th root of x plus 8 over 2. It really doesn't make any difference which method you choose. I'm totally good with both. There's a time and a place for each as you move forward in math. So it's just a matter of what you're most comfortable with. And I know I'm moving before some of you are done. There's a video. All right. What are we at? 18, 17? 17 says f of x equals 3x plus 4 and g of x equals 3x cubed plus 8. All right?
Yeah.
Okay. And you're being asked to find, is it g of f of 5? This is a great place for you to write some notes on that note sheet about what does this mean. If you don't understand it, it means to take the 5, put it into f for x, trade x out for a 5. You're going to figure out what that is. Then you take your answer and plug it into the second equation, the g. So I'm going to start with the f of 5 idea. That's 3, but instead of putting an x, I'll put the 5 plus 4. So I'm literally taking this f equation and I'm just putting 5 in for x. What's 3 times 5? 15 plus 4 is 19. Okay, so f of 5 is 19. Well, the second step to these compositions is to take that number and put it into the other equation. Okay, so the order does matter here. If I put 5 into g and then put that into f, it's going to be a totally different result than if I do it into f first, then into g. So here it would be 3 times 19 cubed plus 8. So again, I'm replacing the x value each time. And this is something, honestly, off the top of my head, I wouldn't know what 19 to the third power is.
6,850.
That, then did you times it by 3? And let's add
2,000 or 20,500.
5.
77.
Did you add the 8?
Plus the 8 is 84. 85.
85. So 2585? 20585. Again, I don't know what the numbers are going to be. I'm not really concerned about that. I'm concerned about processes. Okay? So it's about a double substitution on question 17. If that doesn't make sense to you, you need to start writing down notes to yourself. What am I doing? Why am I doing it? How do I know that's what I'm supposed to do? Okay? But again, just showing an example problem won't make sense when you take the test. You need more than just an example problem. You need explanations. All right, 18 says we're going to solve. It's 2x minus 1 to the 2/3 equals 8. All right, our job is to get x. Can I move the 1? It would be really easy to add 1 here. Am I allowed to do that? No, because it's being held in the parentheses by the 2/3 exponent. So I have to first get rid of the exponent. How do I eliminate a 2/3 exponent?
Times by 3 over 2.
Times what by 3 over 2?
The exponents.
Okay, so it's really important. If you're going to use the word multiply or times, that it's the exponent that's multiplied, not the number. We're not multiplying 8 by 3/2. We're multiplying its exponent. Or we can say we're raising it to a higher power. So we're going to times the exponent by 3/2. We'll use a 3/2 exponent over there. The left side just leaves me with 2x minus 1. I don't know what 8 to the 3/2 is, so I'm going to use my calculator for that. 8 raised to the 3 over 2 comes out to 22.63. It's a decimal. Oh well. 22.63. And it should be pretty easy to finish solving. I'm going to add 1. 2x equals 23.63. And if I divide that by 2, x is 11.8. 8. We'll call it 11.8. All right. So we got 11.8 on 18. Honestly, it might come out as a whole number. It might come out as a decimal. they're going to happen from time to time during the test, okay? All right, let's change colors. Number 19 says, now 19 and 20 are all based around, I'm going to write 20 down as well. It's based around this idea, b to the x equals y is interchangeable with log base b of y equals x. That's a great example of something that might go on your note sheet. But again, if you don't understand this pattern, it's not going to help you to write it down. You need to be able to maybe put some notes in if it doesn't make total sense to you. So number 19 says we have 10 equals 3 to the x. And it says, write this as a logarithmic equation. Do you have a question? Oh, just check. All right, so I'm going to write this as a log. I want it to look like this thing over here. But I need to know what's b, what's y, and what's x in this problem. So what is the base of my logarithm? What's the b in this problem? 3, because it's what has the exponent. So that 3 is going to go right there. Okay. How do I know whether the 10 or the x goes where in these two? Carson, what do we got?
We want to find the x, so we would put it after the equal sign.
Logarithms always equal the exponent. Since the exponent was x, the exponent will be alone on the other side of the equal sign, leaving me with the 10 to go in there by itself. Does the problem ask us to solve for x?
No.
No, it just says write it in logarithmic form. We will solve later. If you were to tell me what the log base 3 of 10 is in this problem, I wouldn't mark it wrong, as long as I saw this process first. Okay? So please make sure you show this. Now 20 says simply, can you go backwards with it? Okay, it's 6 equals log, there's no base, and it's of 2x. Okay, I want this to look like number 19 started. So I'm trying to reverse the order here. So I'm missing the base. That's one thing that's kind of an issue. I don't see it. Is there something I can imply or, something I can infer?
10.
That it's 10 because that's our standard base. If there's no base listed, it's always 10. Okay. If I look over here at this version, I think I want to start by finding b. What is the base in our problem? It's 10. But what's the exponent that that base gets?
6.
It's 6 because the logarithm always equals the exponent. So if it's equal to 6, 6 must be the exponent. What have I not used?
2.
The 2x. Did I get asked to solve this? No, so I can stop here. I've turned a logarithm into an exponential. That's really important because when we hit two problems later on in this test, you've got to be able to do that step to be able to solve. These I could solve. I could figure out what 10 to the 6th is and divide it by 2. Wouldn't be a big deal. But I couldn't have solved it without moving it to that form first. Okay, so we're on our last page. 21 and 22 are about expanding and condensing the logarithm. So this is sort of that accordion approach. 21 starts with the log. We assume it's base 10 of 2x cubed over 3y the fifth. All right. So the first question I always want to ask is how many different pieces are inside the logarithm parentheses? And I think about, can I separate them by multiplication or division? The 2 and the x are a multiplication problem, right? And the 3 and the y are a multiplication problem. So I see 4 pieces. The 2, the x, the 3, and the y. So I'm going to write logarithm 4 times with parentheses. And in each of these, I'm going to put one of them. 2x cubed, 3y to the fifth. I next need to figure out, are they pluses or minuses that go between these logarithms? Anything that's on top is addition. Anything that's in the denominator is subtraction. So this first log came from the top, so it's positive. Second log is also positive. and then I will subtract the log of 3 and the log of y to the fifth, because they both came from the denominator. There was only one other step I can do in expanding logarithms. Our exponents can come out in front of the logarithm that they're attached to. They don't go to all the logarithms, only the ones that they're connected to. So my final answer here would be the log of 2 plus 3 log of x minus log of 3 minus 5 log of y. So there's our fully expanded. We pulled this all the way apart. Question 22 asks, could you take one like this and put it back together into a single logarithm? Okay. I'll just pull the page down a little bit. All right, 22 starts with, we're going to condense a logarithm. It's the ln of 3 plus 4 ln of x minus 2 ln of y. Now, I tried kind of hard, but I know I don't always get the best. That 4 ln, there's a space between them, and the 2 ln, there's a space there. Try really hard not to think of them as 21 and 41. It's really easy to mistake them. That's why I'll write them in cursive when I write them in hand. Okay, so I want to squish this all together into one single logarithm. Because it was ln before, it'll stay ln. First question Mr. Welch will ask is there a fraction in this log? Yes or no? The answer is yes. What tells me that there's a fraction? The negative tells me that I have to have a division bar. Now, I'd like to just start putting everything in. Okay, everything that's positive goes to the top. Everything that's negative goes to the bottom. That means I'm going to have a 3 and an x. The y is from the negative, so it will go in the bottom. But what am I missing? 4 and the 2. What does this 4 and this 2 represent? They're exponents. So that really goes on the x, and that really goes on the y. So this is x to the fourth and y squared. If you think about it, you should be able to see how taking this one apart would create what we had in 22. You'd have 3 and x to the fourth in their own positive logs, and then y squared would go into a negative log, and then we pull those exponents out as coefficients. All right, that takes us to question 23. There are 3 different ways to do this. Log base 3 of 9. Can that be put in the calculator? Yes, it can. I'll show you how, but guys, this is not intended to be done in the calculator. If I needed to, I would press the math button, scroll up till I can find that log base, because it's not a base 10. I'll put the 3 there, I'll put the 9 there, but I'm not even going to press enter. I'm going to come back over here. You guys could do that anytime you want. But a logarithm is asking, what exponent do you put on a 3 to get 9? Now, some of you will make a mistake and say 3 because you're thinking multiply, but it's a log, which is an exponent. The answer is 2. 3 squared is 9. The question that I'm going to give you on the test for 23 should be very straightforward. You should be able to calculate it without a calculator. But do you have your calculator? Do you know how to use it? It's not a problem if you do. Okay? But I want you to understand that logarithms can be understood and interpreted by us if the numbers work well. Okay? 24 and 25 go back to number 19 and 20. If you can do 19 and 20, you should be able to do 24 and 25. They are very similar. 24 starts with 3 to the x minus 4 equals 65, 61. Did I do that backwards? Yeah, 65, 61. So we're going to go ahead and try to solve this for x, but x is in the exponent. So how do I get x out of the exponent? I create a logarithm. Okay? This is going to become a logarithm. What's the base of the problem? It is 3. What is the logarithm always equal to? The exponent, and the exponent was x minus 4, meaning the only thing I haven't used is the 65 61. Pretend that's a 1 in there, so you can see. Can I evaluate the log of 65, 61 with a base of 3? All right. All right, so I'm going to do that. I'm going to do math. Oops, clear this. I'll just come in here. It's already base 3. And I'll put 65, 61. Evaluate comes out as 8. Which means I have 8 equals x minus 4, making x equal 12. But if you can't get the exponential into logarithmic form, it's a guessing game. You'll be guessing for 10 minutes trying to find the right value of x. You probably wouldn't have come up with 12 as your first guess, and it would have taken you a little while to get there. 25 asks us to go backwards with the same process. It says 4 equals log base 6 of 2x minus 8. Bless you. All right. We have the variable inside the logarithm, and because it's inside the logarithm, we're going to try to get to the exponential form. We're going to reverse this process we did over here on 24. So what's the base in our problem? 6, right? Boom, there's my base. What's the exponent in the problem? And if you're struggling with this process, you go back to number 20 and look at what you did there. The exponent should be 4. Because logs always equal the exponent, leaving me with 2x minus 8 equal to that. 6 to the 4th can just be put into the calculator. And if we do, we get 1296 equals 2x minus 8. I'll add 8 to get 1304 equals 2x. And if I divide by 2, x equals 652. Now, as a side note, this is really important to identify. This started as a logarithm, and it's not that common that you end up with a no solution, but we should check our answer if we started with a logarithm. If I put 652 in here, is that going to come out negative? Or is it 0? Would we agree that 2 times 652 is a big number? And then if I minus 8 from it, it's still going to be a big number? Yeah, we're good. That number is valid. If, however, you plug that in and you get negative 3, you have to reject it and say no solution. I'm not saying that'll happen on the final. I just don't remember what the final question is. And so it's possible. Okay? I don't want to mislead you. We've only got 2 left, and they go back to the calculator to graph. These were our exponential growth and decay functions. So 26 and 27 are really straight off the calculator. 26 is negative 1/2, parentheses 4 to the x. So that should be y equals. And over here on 27 we have y equals 1/3 to the x. We're going to graph the 2 of these functions on a simple coordinate plane. And I didn't even make you give me the domain and range, which I could, but I'm not requiring it. Just make sure that you can get the graph done. So I'm going to start this one with go to the y equals, clear everything out. I'm going to type negative 1 divided by 2. And then I want to start a parentheses, 4, close parentheses, raised to the x. If I graph it, do we have a growth function? No. Well, yes, we do. I know it's growing negative, but it's getting bigger in size. So this is still considered a growth function. It's just a negative growth function. So all we need to be able to produce this graph is the asymptote boundary line that it approaches, and then 2 points. Okay? So I'm just going to go to the table to get a couple of points. Like 1, negative 2 looks really good, and 2, negative 8. So let's do that. I'm going to come over here to 1, negative 2. and 2 was at -8. 3, 4, 5, 6, 7, 8. The question is, where does it flatten out at? In the graph, it just sort of disappears. Right? If we look at that graph again, we can see it's coming from up here, and then where does it go over here? What's happening on this left side?
Slowly, but it's never going to hit 0.
It'll never quite get to 0, but it's approaching it. So we like to draw in a boundary line, what we call an asymptote. It's important that you draw it in on the test because this is how I know you know what you're doing. If that asymptote's not there and you accidentally cross it without that dotted line there to kind of guide me, I don't know what you're doing. Okay, and that kind of helps guide you as well. Okay, there's your growth function, negative growth function. Well, we should be able to do the exact same thing on 27, except with the decay function. It really won't make any difference in the way we do the problem at all. We'll go to y equals, clear this out. You do need to make sure you use parentheses around the 1/3 when you raise it to the x. It's really important that the calculator understands what you're asking for. And we see this graph, it dies off. It flattens out as it goes to the right. So that makes this a decay function. Again, I need a couple of points. Let's see, -1, 3, and 0, 1. So -1, 1, 2, 3, and 0, 1 would be right there. Where's the boundary line for this one going to be? If you go back to that graph, it's also at 0. You can always tell because it will be a number that's added at the very end of the problem. If it says -2, then it's at -2. If it says +4, it's at +4. If there's nothing there, we default back to 0. So this graph will come tailing down and then follow the line. And that is it.